Hi everybody, welcome back. Last time we were talking about using the flip command to simulate what happens, something that happens randomly. We used it to flip a coin, and the coin is either going to land on heads or tails. Um, Now what we're going to do is we're going to take that and use that to help to simulate our bike share. Um, if you remember further back, we were talking about using the commands bike to Olin and bike to Wellesley as the way that we transition a bike from one place to the other. Right? We have Olin, we have Wellesley, and bikes are moving in both directions. And so what we want to try to do is we want to try to simulate what a normal day looks like. A normal day looks like, and we'll break that down into a normal minute. So at any particular minute, we can ask the question, how likely is it for a bike to transition from Olin to Wellesley and also from Wellesley to Olin? So how likely is it in any 1 minute? Right, and so this 1 minute we could decide maybe it's actually every hour, or maybe you can decide every 5 minutes. This is just some decision that you're going to make as you're working on the problem. Furthermore, these probabilities that we come up with, these are also things that you're going to make assumptions for. Is this something that you know from historical data? Is this something that is prescribed by maybe your boss as you're creating the model? This is going to be an assumption, and so let's just go with some basic assumptions. So let's say our first assumption is a bike leaves Olin every 2 minutes on average. Okay, so a bike is leaving Olin every 2 minutes on average. So we need to turn that into a probability that a bike is leaving any 1 minute. So this corresponds to a probability of something that a bike is going to leave to go from Olin to Wellesley every minute. Okay, so what is this probability? So if every 2 minutes approximately every 2 minutes, the bike leaves Olin, then that's saying that every minute you have a 1 in 2 chance that the bike is going to leave Olin. So a probability of 1/2 or 0.5. So we're going to use this as the probability that a bike leaves Olin for Wellesley. And maybe we say that a bike leaves Wellesley every 3 minutes on average. All right, if we make that assumption, looks like a lake, it's a bike. If we make that assumption, then we would say, oh, this corresponds to a probability of 1/3, or which we can approximate by 0.33, that a bike goes from Wellesley to Olin. All right, so we're going to use those as our underlying assumptions for how likely it is that a bike goes from one to the other. And now what we'll do is we'll simulate this 1 minute in time. So simulate 1 minute in time. Okay, so for this minute in time, we have a probability that a bike is going to go from Olin to Wellesley. So we'll use the flip command. So we'll say if flip of 0.5, right? So that's going to be true half the time and false half the time. So if it's true, what are we going to do? We're going to send a bike to Wellesley. Bike underscore to underscore Wellesley. All right. So if a bike leaves, we're going to send it to Wellesley. We're not going to use an else statement because if the bike doesn't go to Wellesley, nothing happens. On the other hand, we can ask the question, we also have the dynamics of the bikes going the other way. So a bike going the other way happens 33% of the time. So if we're in that 1 out of 3 chance that the bike goes from Wellesley to Olin, we want to send the bike to Olin. Bike to Olin. All right, so these commands simulate 1 moment in time. Great. Since this is 1 minute in time, and maybe we'd like to simulate a whole hour, it's probably best if we define a function that does this. So let's take all of this and we're going to put this into another definition. We're going to define step. And what step is going to do is it's going to do all of these things. So step, when I think of step, what I think of is I think of it simulating 1 minute in time. Okay, it's one step in the simulation. Okay, so that's what the step function is. Let's go over to our code and practice that. All right, so here we are. I've evaluated everything above. I've made sure to define bike to Olin. Don't forget to do that. And so now we set this up. We have bike share. We have because we used it a number of times above, we maybe sent bikes from one place to another. It's always good to maybe start with a clean slate. And here we've redefined bike share to be what we defined it earlier to be, which was Olin has 10 bikes, Wellesley has 2 bikes. So here's the code that we were just talking about sending a bike to Olin, sending a bike from Olin to Wellesley. Here's the code of sending a bike from Wellesley to Olin. And so here's our function step. All right, so now let's run step. So remember, defining the function doesn't actually do anything. Doesn't run the function. It now puts this into the dictionary that the computer has available for us. And so now when we call step, it's going to move possibly some bikes from Wellesley to Olin and Olin to Wellesley. All right, so here you're seeing some text. And in order for us to maybe get a good feel for what's happening behind the scenes, what we can do is we can give ourselves some information. So in addition to the way the step function was defined before that I was writing down, we can also add in this print statement right here. So if flip of 0.5, send the bike to Wellesley, and print that we've sent a bike to Wellesley. Similarly, when the bike is sent to Olin, print something that says we're sending a bike to Olin. And this may help us just to keep track of which way the bikes are going, just as a visual way, because if you look at what we did here, running one step of this function, running 1 minute of the function, a bike moved both to Wellesley and to Olin at the same time. We wouldn't have noticed that anything happened because the bike share, the number of bikes in both locations stayed the same. Run it again. Again, a bike was sent both directions. This time, no bike was sent either direction. This time a bike was sent both directions. I'm just trying to get an example where it's only sent in one direction. There were a lot of times when no bikes were sent at all. And here's an example, finally. It took a long time for me to generate, and that's normal with randomness. You never know what's going to happen. You run the step. Here, a bike only went to Wellesley. All right. I think I'm going to stop here, and I'll pick up with taking this and making this a bit more general and a little bit more useful in the next video. All right, thanks.